Nice small crowd this morning. Everybody must have partied a little too hard last night, apparently. So, to be honest, I was counting on that a little bit. So, I'm not going to complain. Is anybody in the room familiar with Genesys or anything that we do? Probably not. You may actually use us and just don't even know about it. Genesys basically is a customer experience company. They've been producing telecom software for almost 30 years now, writing SIP phones, doing voice over IP, providing on-premise call centers, as well as other proactive communication, outbound texting, outbound emails, and things of that nature. So the last few years have been very focused on cloud and delivering our platform as a service rather than physical call center situations that we have now. We've been using, whoa, that got way louder. We've been using Genesys or Akamai solutions at Genesys for a little over a year. Initially it was to provide reliability, the ability to secure our origins, both physical data centers and at AWS, isolate traffic for all of our customers. We have a lot of financial institutions, credit card companies, HIPAA compliance, and other very large businesses, and they choose to have all of their traffic individual from the rest. We also use it to leverage the WAF environment. Much easier to put the WAF at the edge rather than having to maintain it across the 20-some data centers and AWS regions that we have. And then also to support automation for DevOps. The current model, or the model that we did have, involved a call agent signing into their desktop. We'd route traffic into Akamai, into AWS, into Genesys, and then Genesys Transit Network initiates outbound phone calls for customer service. Example of what our agent desktop looks like. Audio keeps going in and out. So agent desktop, when somebody sits down at their desk, it's a thin client that they download over the web. Log in, set your place. You're able to receive calls through a queue. You're able to make outbound calls through that same queue, take notes, and do all of your customer service information through there. Also provides the ability for time tracking, lets the managers know who's been taking calls, how long those calls have been in process, voice recordings, screen recordings, all that provided through our thin client. At the Akamai layer, we were using the web application firewall. We also have unique customer configurations, so every customer configured in Akamai has their own CP code. We use that for portions of automation, as well as analytics and reporting, pulling logs. Everything is tracked per customer. We also have some shared services that we offer. Those are also their own individual CP codes and able to track those. Using two separate web application firewall templates. I'm not sure if folks are aware, but in the past, Akamai only supported one single WAF configuration, and everything had to be done within there. As of a few months ago, I noticed the ability to be able to create now, I believe it's 5 or 6 individual WAF configurations. We also create templates for the web application firewall, properties, and then I'll be getting into the application load balancer. I have the ability to clone those, modify the default values, and deploy customers or new services into the cloud within roughly 2 hours. And most of that is the actual deployment time within the Akamai infrastructure. We utilize CDN for caching of static content at the edge, as well as net storage to serve out some static content directly from Akamai. We utilize some of the analytics portions of it, see where our traffic is, what our error rates are, And then we use Site Shield for securing the origins at AWS. It allows for the ability of limited sets of citers being able to contact origin, and we don't accept then any other traffic from the public internet. Once traffic leaves Akamai, this solution is now routing into AWS, where we function in 8 different regions within AWS and have multiple VPCs in every one of those regions. All of our services run behind redundant ELBs. So if one fails, the other one automatically takes over. They're also in a load balanced pair. So not any one is getting overloaded. Everything leverages security groups, and that's where the Site Shield portion comes into play. So at the ELB layer, there's a number of security groups accepting the traffic and allowing that from Akamai. All the DNS that we do for our production environment is via Route 53. Nice and easy to script against, and we have not had any reliability issues with that. A lot of data stored then for the customers into the S3 environment, and the number one reason we're in AWS is for sheer scalability. Once traffic hits the AWS environment and goes through a number of applications, Genesys owns their own transit network. We're able to route calls, route traffic, record data, share data with clients. Clients can have VPNs or MPLS connections into our network. And we also utilize that same network for syncing data between AWS nodes. And a little bit later, you'll see why that's advantageous for us. A bit of a unique situation. Not all companies have that capability for a high-speed transit network around the world. Some of our tenants require that their data stay in their own stack. So all the applications are independent then per customer. Nobody else shares those instances. But along with that, we also have a multi-tenant environment. So those customers that choose not to want to pay as much money or don't need the throughput that others, you can run on a shared architecture. We also have a number of shared services that are applicable to all of our tenants. Having our own network provides an extra layer of security, and where we do call routing, proactive communication, and a new feature that is being worked on, and I believe beta availability is called Kate. Instead of interacting directly with a customer agent all the time, it's a blended AI, so you may have live interaction, you may have some automated interaction along with that. And really what we're trying to get to in that solution is an outbound call with no jitter, no time lag, providing a great customer experience. A few months back, I was presented with a unique requirement. We have one particular customer. As you can see, they existed in 4 different regions. So an agent needed to know where they were sitting in the world, click the appropriate tile, and then be directed into their data center. Those were US East, US West, EMEA, and APAC. The ability to control that was very difficult. There was nothing preventing a customer agent sitting in EMEA and connecting into the West Coast and initiating calls from there. So that was a huge challenge. It really did rely on the customer agent knowing where they sat. So our old model looked a little like this: 4 primary regions, everybody connecting into Akamai, and then that routing into the associated AWS region. To get around some of these issues, we began to look at a load balancing solution, putting all the traffic behind a single URL, behind a single tile, and then attempting to utilize geographical load balancing and routing for that specific for that specific requirement. This enables us to have automated DR for customers which may have one primary site and then a hot standby, or they can function in a fully active type situation across a number of regions and data centers. The application itself requires an open connection in and out of our environment, so we utilize long polling at this point in time, and hopefully in the future we'd be switching that to a WebSocket for a little bit better security and just overall better performance. Some of the solutions that we originally looked at were from F5. I don't know if any of you use F5. You require, either a physical device or a virtual device in every region. They have to be scaled appropriately. You mess with iRules constantly. While they do provide a GTM solution that I've used in the past, it didn't really fit all of the needs that we had, especially once you start routing through Akamai. AWS also provides some ability for GTM through Route 53. You can configure a URL, create other paths and routing behind that. But one of the big issues that we found during testing was really reliant upon DNS, TTLs. So our failovers took sometimes up to 15 minutes before a customer actually saw a new route in traffic. We also looked at writing in-house software. We do have a very large engineering staff, but it was pretty quickly decided that other companies must be doing it. Why should we go through the effort of trying to code our own and learn all that logic and just make a giant mess of it? In the past, Akamai only had a GTM solution, which is all good and great. Lots of companies use it. Requires a lot of advanced programming. You need your own logic for the failover scenarios. And in routing into AWS, there's really no easy way to define all of the GTM nodes that Akamai leverages. Literally thousands of those need to be configured, and ELBs do not support that. And then lastly, we were alerted to the ability to be a beta tester for Akamai's new ALB Cloudlet. We've been working with Akamai for about the last, I believe, 6 or 7 months, going through as a beta test, doing load tests, failovers, bug checks, feature releases, things of that nature. What it really affords us is that true active-active environment, especially when you're talking, 4, 6, 8 different regions. We can distinctly, either through performance load balancing, send those there, or we have the ability to define, by URL or by geographical location, specifically what data center they are going to hit. We utilize the liveness checks across all of our applications. One thing of note in utilizing liveness checks, if you use Site Shield, you need to ensure that the liveness checks are only coming from known good Site Shield addresses. The default is to use all of the GTM nodes. In that case, you get what appears to be site failures or site down conditions, and it really messes with all of your logic. It allows for easy failover in an automated fashion or a programmatic fashion, and then as well as failback. Right now, failback scenarios are maybe a little bit of an issue. There's a few ways to look at that. With the type of traffic we flow, the question is always, do we fail back immediately? Do we do health checks to ensure that the site is up? How do we detect a site that may be flapping, coming up and down, as well as the loads in the other region? We also have to take into concern that since we have traffic initiating and being connected from all over the world, certain countries have telecommunications requirements, legal issues surrounding that, data sovereignty. Those would be specifically Australia. They like to keep all of their data in their own country, on their own networks, data stored where they have in their country, and then Europe with some of the new sanctions that are going to be coming out. I believe it's 2019. We'll also have to be looking at advanced failover scenarios. So instead of before, where we had a whole bunch of agents needing to define where they were connecting into and only having a single static route into a data center, we now have one global URL, which also happens to support single sign-on, which is a huge feature for us. That then routes into the application load balancer, goes through, leverages Kona, all the other rules that you're able to enforce for security through there, and then out through Site Shield into any one of the AWS regions that we have. From there back into Genesys again, and we initiate calls, do all of the traffic at that layer. An example of some of this routing and failover is agent launches their desktop application. They hit the load balancer. The load balancer then goes through the sets of logic, looking for what regions they're in, performance weighting, site failures, ups, downs, delays or latency, and then it picks a primary region. In this particular instance, USW would have been selected, and we have US East as a hot standby. That traffic then routes into Genesys, and we initiate and fork off a call session on the back end. In the case of a failure, say USW just gets yanked out from under you, the traffic within a matter of seconds automatically cuts over to routing through the US East data center, and due to the nature of single sign-on and error checking within our application, the agent session re-authenticates. All of the data has been synchronized between AWS regions via our own transit network, and then that agent session is reattached to the call, all of their notes, all of their data. They don't lose any of it. The call never drops because it's either routed to a desk phone, a soft phone on the agent's desktop, cell phones, those initial points, and that traffic is completely separated from Akamai and other routing at that point. So it ends up being a very seamless and automated failover for this type of application. There's other applications that Genesys is using and what we'll be putting behind the ALB. Those also will have automatic failovers, automatic login, synchronization of data across the back end. Some of the challenges that we initially faced, since this was at the time a beta product, I believe general release for Cloudlet was just in the last month, and a number of the talks here this week have been surrounding that Cloudlet specifically. Timeouts were a big issue for us since we do utilize long polling. Some of those responses are 30 seconds with no data returned. Initially, Akamai was detecting that as a failure and changing our route for us. Those have since been extended, and I believe if you work directly with the technical support teams, you'd be able to get those timeouts adjusted and configured to work with your applications. The failover and failback logic initially was a bit troublesome. We had a situation where something would fail, and then both regions would be live, and it would skip back and forth for undisclosed reasons. Another one is if a site went down, your session failed over. As soon as the old site came back up, your session automatically failed back. One of the features that they implemented for that is a retry scenario. So they don't necessarily automatically assume a site is down. They can go through a 3-try iteration of delivering that same traffic. You don't see it at the client side. That's all handled within the Akamai environment. Utilizing Site Shield, as I alluded to a little bit earlier, was a huge issue for us. The GTM nodes, which were doing the testing, like I said, indicated failures. We went through a whole bunch of scenarios trying to get all of the GTM nodes whitelisted, and only to find out that all that effort was pretty much wasted, because since we only accepted site shield traffic for valid customer traffic, the GTM nodes may have showed up, may have showed down, may have showed latency, and that really didn't reflect the traffic that we were supposed to be accepting from Akamai. Working with their technical support teams, we're able to get that changed over, and now all the liveness checks follow the same logic that the rest of the traffic does, and leverages those site shield and secure origins. Logging for the cloudlets is not as robust as logging for other devices. I believe that's coming along very quickly, and some of the demos downstairs in the Cloudlet booth indicate near real-time analysis for your Cloudlet traffic. I'm not sure when that will be released, but it definitely looks like Akamai's been working on it. As anybody can guess, with the beta service, there's always going to be some uptime issues. They don't really fall into that. If something's not working, everybody's online at 2 a.m. Trying to resolve it, and then also going through changes and bug fixes with Akamai. They've been fantastic to work with. I suggest that if any of you folks have the opportunity to go through beta test and try out a new product, that you take advantage of it. However, don't utilize it for live customers. I learned that the hard way. Don't make promises you can't keep. The future and kind of where we're looking, another project that I'm working on at Genesys is a fully automated DevOps pipeline. Being a part of the security team, there are huge issues surrounding that. Developers want to write their own code, build their own code, submit it into production, modify it, change it, have complete and full control. From a security standpoint, it's incredibly dangerous, and the way that you go about trying to define that is difficult. So right now we have a scenario that's actually being tested through the ALB, where the engineering team writes their own software that gets built into a Docker image. That Docker image is then submitted for an automatic vulnerability scan. If it's reported as good, it's allowed to go into production. If it's reported as bad, it kicks back all the findings to the development team, and they can go through and fix and rebuild until they get something that's clean. Those images then get loaded into AWS, into an ECS cluster. From that ECS cluster is created through CloudFormation, and a number of other CloudFormations control the auto-scaling, what's able to be pulled into it, how that functions, and engineering teams then can maintain and manage their own application stack through IAM roles. It's all restricted to their own cluster. They are no longer, they're not able to modify other applications, see other applications, see any database or network traffic for other things. Their entire application lives inside of one cluster stack. That provides us immutable infrastructure. You run into a problem with your application, you kill that container and just launch a new one. It also, for self-provisioning services, helps hugely, because we can have other containers that if a customer wants to modify some aspect of the application on their side, the application can launch a new container, it runs a command, and then that container is immediately torn down. So we have guarantee that we don't have long-living applications or services being able to modify data anywhere in our environment. It has to originate within that cluster. Genesys is also going into a lot of social interaction, be able to leverage social media, Twitters, Facebook, and another bunch of other proactive communications, direct pushes to cell phones, things like that. And AI is also hugely advantageous and seems to be the direction that a lot of companies are trying to go. One, it cuts out the human factor for customer service. If you can be online and bring up a chat and interact with an AI, you most likely will get to your resolution much quicker, as well as hopefully having a more accurate response from that. So with that, I think we have a little bit of time left. I'll open up to questions. I know I kind of sped through things, so if there's a slide that you want to go back to or any particular part of the environment, just let me know. Yes? So before using the Cloudlet, were you using like Route 53 for origin? Yeah, we definitely were using Route 53 and then attempting to use our own custom configurations for GTM. We looked at a bunch of different situations, but the failover times were always on the order of, probably closer to minutes, somewhere in that 5 to 15 minute range before we truly had a solid functioning environment. Going to the ALB, the average time has been just under 3 seconds for a full failover to the region. And since they're in AWS, they auto scale. So if they're sitting in an active situation, initially all the loads are fine. If one region dies, the auto scaling in AWS is able to ramp up within 10 to 30 seconds and be able to start accepting all of the traffic out of that other failed region. So we really don't run into a lot of performance issue there. Yep, yeah, so in addition to the failovers through Akamai and getting some alerts there, we also have all of our own health checking, other services that are going out and polling. We also run synthetic transactions out of Azure, completely separate environment. That's all it does is live test the application for us. So it's not involved anywhere in the rest of the equation, so that we're not running into issues there. So. Yes?
So it seems like this is all fairly automated with the failover and the fallback. Do you ever have situations where you use ALB for manual failovers?
Yep, yeah, so we can do manual failover. You can go into the Cloudlet and just redefine the loads. So if you had two regions and you're in a performance type situation, both of those would be a 50-50. If you wanted a manual failover, you just simply go in, change it to 100 in the region you want primary, 0 in the other, and you can initiate the failover that way. One of the features that I have not seen is a graceful drain. It doesn't seem to persist any connection. If it sees a site's down, that site is just down. I don't know if that will be added in the future, but a request that we've had for some of those manual situations. The other way to manually fail it is just turn off your internet connection to that region, or pull the DNS record for it. So there are a few ways to initiate manual failover. Anybody else? Oh, I personally have not played with that, to be honest. So that may be a newer feature that I've not been involved with yet.
Yeah, I think it's like that's like a newer feature, and it kind of gives you that direct generation of you take a data set and any users to that data set, you able to data centers, and then like these users would still have a stake session.
Anyone else? There's no way I could have possibly covered everything. So. Yes.
How are you doing that? Are you actually just like user session state or just package sort of state?
It's a little bit of our own magic, since we have, create our own software. Within AWS, for those of you that may not be familiar, the distinct regions, if you're running multiple VPCs in those regions, you're able to have peering, sync data, really easy connection. But if you want to interact with another region, that's always needs to be through some form of IPsec or other VPN connection. the advantage that we have with our Genesys transit network on the back end is we have links into all the AWS regions that we leverage. And so we use that, our own private link, to then synchronize data across. We're really heavily reliant upon some of the RDS features in AWS for data synchronization, as well as we maintain our own back-end applications and databases as well. So there are a number of areas where that data could be synchronized. Some of it's at the client layer, some of it is persistent data within the CDN at Akamai, and then all the way through back into our environment. So
for actual like user session state, are you starting out like liveness or something and then replicating that back and forth through your network? Or?
I guess define state.
So I'm thinking of like the actual like user session, like the users log into a web portal or whatever.
Yep.
And you have all the data associated with the session, or the cookies, whatever, data associated with that.
Yeah, that's not through Redis. That's our own back-end applications. Yep. Yeah, and so if you were, let's see if I can go back to the slide and maybe explain this a little better. So in this situation, calls initiated out, you can take notes, do everything else. The agent also sets a state, whether they're on break, if they're accepting calls, if they're in an emergency situation, in a meeting. All of that data is what is persisted and then synced between regions. Everything is load balanced on the back end. Every server has its own unique keys and cookies that it leverages, so that we can, the only sticky session that we utilize in our environment right now is at Akamai. So the agent connects to Akamai, is sticky, and then everything behind there is dynamic and load balanced without sticky session. If we do fail over, part of the way that we're able to reinitiate login is you suddenly get an access denied error, essentially like a 404. We pick up on that, and then through SSO automatically reconnect. You get brand new session data, cookies, but the core agent screen is maintained. And so syncing that across the US is pretty easy. If we need to go into other countries for a failover scenario or have traffic that started in another country, we have to be really careful about what types of data we're sending. So while we're going to need Akamai to create and have logical failover for that, we also have to have that same type of failover scenario replicated on our backside so that we're not putting data where it's not supposed to be going. Does that answer your question? Anyone else? I think we just,
You mentioned you had issues with site shield in your health checks.
Correct.
Is that something out of the box that like you can check or something that only your health checks will be site shield?
It was not. We had to work with the Akamai engineering team. I believe that goes directly into their GTM group, and they do a configuration there, just to ensure that you're only getting checks happening from there. Our checks right now, we found that we really only need to run it at a 30-second interval because it pulls from so many locations and they're all out of step. So we actually see a liveness check, anywhere from half a second to a second and a half seems to be typical. So the liveness check configuration in the ALB doesn't need to be that aggressive. I suggest tuning and playing around with that to find, you don't want to increase the load on your application servers for no reason at all. Yeah, so once it's reduced to the site shield, you're probably testing from a few hundred nodes versus, all of GTM is thousands of nodes, that could be pinging your environment.
Why are you using site shield?
Good question. Mostly for secure origin. AWS can be a bit of a challenge. I don't know if any of you have ever had a situation where you're utilizing a region, everything's going fine. You may, start up a new application or bring in a much larger customer or something like that. AWS at times can detect that then as malicious type traffic, or your traffic patterns have changed, and that they've been known to block traffic through secure origin. The security group, we never run into throughput issues as long as it's coming from the Akamai nodes. AWS just leaves us alone and allows that to happen.